This is Lesson 3 in Unit 6. We're going to discuss binomial radical expressions today. When radical expressions have the same index, such as the cube root of 7, and the same radicand, they're called like radicals. So let's say we had the cube root of 7 and 5 times the cube root of 7. Same index is 3, and same radicand is 7. But there's a warning here. You've got to be careful not to confuse the square root of 16, for example, added to the square root of 25. You don't want to say that that's 16 plus 25, because 16 plus 25 is the square root of 41. When you simplify the square root of 16, that's 4, and the square root of 25, that's 5. 4 plus 5 is 9, and the square root of 41 is definitely not 9. So don't fall into that trap. Combining like terms in radical expressions, let's say when you have the nth root and you have a in nth root of x plus b nth root of x, you want to add the constants a and b and keep them with the nth root of x as like terms. Same thing when subtracting. We want to subtract the two constants a and b and then keep them together with the nth root of x. So let's give some of those a try. In example 1, we want to add 5 square roots of 2x and 3 square roots of 2x. So following our rules, we're thinking 5 plus 3 added together. They both have radical 2x in common. So this becomes 8 times the square root of 2x. And with subtractions, same thing. 8 minus 2, we're going to subtract the constants because they both have like terms, cube root of 5. So 8 minus 2 gives us 6 times the cube root of 5. In part C, 4x minus 9x, they're both square root of x times y. So 4 minus 9 would give us negative 5x times the square root of xy. And lastly, 17 minus 11 is 6, and the common term is the 5th root of 3x squared. So combining like terms is pretty straightforward. You can see how they just behave like radicals. In example 2, we're going to do a little application here. The design of a pathway uses tile pieces that are shaped like squares. And the side length of the square is 15 inches. So that would be these side lengths here, 15 inches. And we don't know what the diagonal is. So we want to think about how many. This looks like there's a half of an x here and a half of an x here. So we do know, using things from geometry, if you have a 45, 45, 90 triangle, and this side is x and this side is x, which is what's happening here, then the hypotenuse is x times the square root of 2. So whatever our x is in any given side here, we know that the diagonal is 15 times the square root of 2. So this is 15, our x is 15 square roots of 2. And we also see that there are 6 diagonals on the path. So there are 6 diagonals on the path. So we could use the fact that we have 6 diagonals, and each of those are 15 times the square root of 2. So 15 times 6, that would be 90 square root of 2 inches, since the length is in inches. This turns out to be, if you simplify with your calculator, that turns out to be about 127.28 inches. And there's 12 inches in a foot, so if you wanted to calculate the feet, that's about 10.6 feet. Looking at example 3, we want to find the simplest form. So the simplest form with the cube root of 250, I'm looking for something common to 250, breaking that down into sets of factors. We could say 125 times 2 is 250. And thinking about the cube root of 54, we could say that 27 times 2 would give us 54. And then for the cube root of 16, I could think of 8 times 2. And what we're seeing here is that we have some common factor of 2 in each one of these radicans. So that's going to give us some like terms here. The cube root of 125 is 5. So we've got 5 cube roots of 2. And the cube root of 27 is 3. That leaves us 3 times the cube root of 2. And then lastly, the cube root of 8 is 2 times the cube root of 2. So our index is 3 in each term, and our radicand is 2 in each term. Adding up the constants, 5 plus 3 minus 2 leaves us with 6 times the cube root of 2, using those properties from the first page. In part B, we have 6 times the square root of 20, so let's rewrite that 20 as 4 times 5. And then the 3 times 125, we could say this is 25 times 5. So our common term is going to be the square root of 5. And simplifying, this would be 6 times 2 times the square root of 5. So 12 square roots of 5 on this term. And this would be 3 times 5 times the square root of 5. So minus 15 square roots of 5. And simplifying one last time would be negative 3 times the square root of 5. So I would recommend that you turn the video off and give part C a try. And then come back to me when you're done. What I want to do is think about negative 3, and then we can take the 18 as 9 times 2 times x squared. And then the 50, do the same thing. We could take that as 25 times 2 times x squared. The square root of 9 is 3. The square root of x squared is x. That leaves the square root of 2. Then we have 2 times 5 times x times the square root of 2. So negative 9x square roots of 2 and 10 square roots of 2. Oh, take that back. Hold on a minute. We need to erase there a minute. That should be negative. That should be 10x times the square root of 2. So 10x minus 9x leaves 1x, and we need that to be absolute value since we had an even index and an odd power, and our final answer is the absolute value of x times the square root of 2. So I hope you did that correctly. In example 4, we're going to multiply binomial radical expressions. So we want to use the distributive property twice, or you may call that foiling. But what I want to look at is I want to multiply 3 times both terms. So 3 times 2 is 6. And then 3 times 4. times the square root of 5 would be 12 times the square root of 5. Then moving over to our next term, we're going to multiply 2 square roots of 5 times both terms. So 2 times the square root of 5 times 2 makes 4 square roots of 5. And then 2 square roots of 5 times 4 square roots of 5 is going to be 2 times 4, that's 8. And the square root of 5 times the square root of 5 is the square root of 25, which is going to simplify to be 5. And 8 times 5 is going to give us 40 on here in the last term. So we have 6 plus 40. And then we can add the 12 radical 5 and the 4 radical 5, and that would give us 16 times the square root of 5. And 40 plus 6 would finalize this example with 46 plus 16 times the square root of 5. And that's simplified. In example B, doing the same thing, we've got 5 times 4, that's 20. And then 5 times negative square root of 3 would be negative 5 times the square root of 3. Then multiplying radical 3 times 4 would be positive 4 times the square root of 3. And then radical 3 times radical 3 is negative, so it's going to be negative square root of 9. And negative square root of 9 is going to become negative 3. So simplifying, we have 20 minus 3. So that's going to give us 17. And here we have negative 5 radical 3 and positive 4 radical 3. So that would give us negative 1 radical 3. Combining these two terms is 17. So our final answer is 17 minus the square root of 3. On part C, again, you can turn off the video and give this one a try and come back to check your work with me when you're finished. So in this case, I want to rewrite the radical 2 plus 5 twice. That way we can see what we're multiplying and not lose track or drop that middle term. So radical 2 times radical 2 is radical 4, and radical 2 times positive 5 is positive 5 square roots of 2, and then moving to this term, positive 5 times the square root of 2 once more, and then 5 times 5 makes 25. So combining like terms, this is 2 plus 25 makes 27, and 5 radical 2 twice makes 10 times the square root of 2. How did you do on that? Did you manage to get the same answer? I hope so. Now, just like our unit on polynomials, we can multiply conjugates. Only some of our conjugates are radicals. So in this case, we have 6 times 6 for 36. And then 6 times the square root of 12. That's positive. And then switching over to negative, radical 12 times 6 makes negative 6 radical 12. You see how those conjugates cancel? And then negative radical 12 times positive radical 12 is just going to give us negative 12. And the reason we know that is because 12 times 12 is 144, and that's just negative 12. So we end up with 36 minus 12 for 24 as a simplified product of those conjugates. On part B, 3 times 3 is 9, and then 3 radical 8 on the negative makes minus 3 radical 8. In the middle, we've got positive 3 radical 8, And then radical 8 times negative radical 8 is negative radical 64. These are gone. And 9 minus the square root of 64, which is 8, leaves us with 1. In part C, you might want to try part C and part D on your own, and then come back to check your work. This one we're going to get 16 times the square root of 6, and then negative 20 times the square root of 6, positive 20, let's make that look like a 6, positive 20 times the square root of 6, and finally negative 25. So these are eliminated, and 16, this would be 36, missed that, 16 times 6, and minus 25. So this is 60, 96 here. 96 minus 25 makes 71. And then moving on to part D, we would end up with 4 plus 2 square roots of 3, and minus 2 square roots of 3, and minus the square root of 9. So the middle terms are disappearing, and we have 4 minus 3. So once more, 4 minus 3 is 1. So those are pretty easy, straightforward. You just have to be careful. We saw rationalizing the denominator in our last lesson. We're going to do that same thing again in this lesson. So this time we want the conjugate, 3 plus the square root of 6. And the reason we want that, in our last example, you saw all of the conjugates. When we multiplied by conjugates, the final result in each case was a whole number, just an integer, each one of those. So we want to use that piece of information when we're rationalizing denominators, and we have a binomial in the denominator. So let's see how that would work with this first example. In the numerator, we're going to end up with 4x times 3. So 4x times 3 is going to give us 12x. And then 4x times the square root of 6 would just be 4x times the square root of 6. But saving some time, since we know that the outside and the inside add up to 0, we really just need to think about the multiplication of the first two terms, that's 9. And then the last two terms, that's the square root of 36. So square root of 6 times negative square root of 6 is going to make negative square root of 36, which is just negative 6. So we have 9 minus 6 in the bottom. And then cleaning that up, the numerator, we cannot add those two terms. They aren't like terms. But the denominator, 9 minus 6, gives us 3. So that can be simplified. And then we want to clean this up a little bit. In part B, our conjugate is going to be the opposite sign of the denominator. So I want my conjugate on the bottom to be radical 3 minus radical 5. And whatever I do to the bottom of the fraction, I want to do the same thing to the top of the fraction. And then we can distribute. So 2 radical 7 times radical 3 is going to make 2 times the square root of 21. And 2 times radical 7 times radical 5 is going to be negative 2 times the square root of 35. And same thing on the bottom. If we have radical 3 times radical 3, that's going to be 3. And then radical 5 times negative radical 5 is going to be minus 5. Combining those like terms, we can get 2 square roots of 21 minus 2. Well, since they both have 2, let's factor out that 2. Let's look at it that way. So we can say 2 on the top times the square root of 21 minus the square root of 35. And I'm planning ahead because I saw this little section, 3 minus 5. That's going to be negative 2. And we can remove a positive 1 and move the negative up to the numerator. So we have negative times the square root of 21 minus radical 35. You could stop there, or you could continue on and say that's the positive square root of 35 minus the square root of 21. This looks a little bit cleaner to me. I'm going to choose to do that. And then finally, part C, that's the one for you to try. Turn off the video and then come back to check your work here with me. So again, I've got my conjugate pair is going to be 1 plus the square root of 2 because I need the opposite sign on the bottom to eliminate the square roots. And on the top we have 1 plus the square root of 2 plus the square root of 2, and then square root of 2 times square root of 2 is square root of 4. And then on the bottom, we only care about the outside in the last term, so 1 times 1, and then negative square root of 2 times negative square root of 2. So this is going to simplify to be 1 plus 2. That gives us 3. And here, these are not canceling. They're both positive, so we're adding 2 square roots of 2. And then on the denominator, it's negative 1. So bring the negative up to the numerator, and that would look like negative 3 plus 2 square roots of 2. This time I'm choosing to stop right there. A little different than letter B. And then our last example are 3 problem-solving type things. The diameter of a pumpkin is related to its weight and can be modeled by this formula, 3 1/4 times the weight under the radical. The diameter is D, and W is the weight, and we have a pumpkin who weighs 6.84 pounds. So you need a calculator for this problem. 3 1/4 times 6.84 pounds is going to give us the inches. The diameter is going to be in inches. So the diameter is radical 3 1/4 times 6.84, and I'm getting an answer of 4.715, and that would be the diameter of my pumpkin in inches. Let's look at part B. The area of a rectangle is 12 inches squared, and the length is 2 plus the square root of 2 inches. We want to find the width. So we know the area formula is length times width. And if the area is 12 and the length is 2 plus the square root of 2 inches, we want the width. So we could find the width by taking 12 and dividing it by 2 plus the square root of 2. Well, that means we need to rationalize that denominator. So we can do that with the conjugate of 2 minus the square root of 2. And if we multiply top and bottom, we'll find out that the width is 24 minus 12 square roots of 2. And then the conjugate pair, this times this, is going to give us 4. And radical 2 times radical 2 multiplied together is going to give us negative square root of 4. And negative square root of 4 becomes subtract 2. So 24 minus 12 divided by 2, we could simplify that. Let's think about this. 24 minus 12 divided by 2. 2 divides 24 12 times, and 2 divides 12 6 times. So our simplified answer is going to be the width, and that answer is in inches. So the width is 12 minus 6 square root of 2 inches. Just to save time, I'm not going to get a decimal answer for that. We'll move along. And in this last question, they've given us a picture of a dog park. It's in the shape of a triangle, and it has a walking path that divides the park into two parts. This is our walking path. If you walk the entire perimeter of the park, how far will you walk? And then the second part is what's the total area of the park. That would be inside here. So thinking about perimeter is the distance around. So I'm going to start at 800 and then move to 400. So I'm going to go this way. 800, 400, 400 radical 3, and 400 radical 6. So we want to add those together. 400 radical 3 and 400 radical 6. And each measurement is in feet, you can see here. So the perimeter is 8 plus 4, that's 1200, and then we have 400 in common, radical 3 plus radical 6, and this answer is in feet. And if you wanted to, you could get a calculator and give an estimate. So that's the first part. The second part is to find the area. So area, we want to do two triangles, and the area for a triangle is half of the base. So I'm looking at this triangle here. Half of the base, which is 400, times the height, which is 400 square roots of 3. And then the other triangle, we want this area. Using the same formula, that would be half of the base. So 400 radical 3 times the height, same thing, 400 radical 3. So half of 400 is 200 times 400 times the square root of 3, or 80,000 radical 3. And half of 400 again is 200 radical 3 times 400 radical 3. This piece is 200 times 400, that's 80,000. And then radical 3 times radical 3 is just 3. So that would be 240,000 plus 80,000. So our area is going to be 80,000 times the square root of 3 plus 240,000 square feet. And again, just for saving time, I'm not estimating that or approximating. That's the end of lesson 3. Until next time.